Chapter 8, Gravitation. Yes, gravitational force. It's scalar form, it's vector form, superposition principle. What is value of G? How to find value of G with the help of experiment performed by Cavendish. Yes, we have discussed. Now force. Okay, if force is acting on object, so according to Newton's first law of motion, if resultant force acts on object, it means that object experiences some acceleration. Object experiences some acceleration. Okay, yes, on surface of Earth, each and every object experiences gravitational force of Earth. So, if object, for example, I have this chalk, and if I drop this chalk, then this chalk, it will move towards center of Earth. So first question, why this chalk is moving in downward direction towards center of Earth? And yes, as it is moving, it is performing accelerated motion. So what is its acceleration? And how to find that acceleration? Okay, so yes, it is clear. Acceleration is produced due to gravitational force of Earth. So how to find that acceleration? And that acceleration is towards, we will see. Okay, title is Acceleration due to gravity of Earth. Yes, we know that Earth is, we can consider Earth as a sphere. We can consider Earth as sphere. Sphere means how we can draw a sphere. So we can assume that a sphere is made up of number of spherical shell. Number of concentric spherical shell. Yes, we can assume. Okay, for example, first shell, second shell, third shell, shell. Yes or no? Yes, it is. Okay, so in such a manner, we can assume that okay, Earth is made up of spherical shells, concentric spherical shells. So yes, first statement I will write K. Earth can be imagined to be made up of number of concentric shells. Okay, we can assume that Earth, which is sphere, is made up of number of concentric spherical shell. The smallest shell at center and the largest shell at surface. Yes or no? Yes. We can assume that this sphere is made up of numbers of shells. Okay, and it is their center. Clear about these statements? Okay, we can assume that Earth, which is sphere, is made up of numbers of concentric spherical shells. The smallest shell at center and the largest shell at surface. Now remember, in previous lecture we have discussed gravitational force due to spherical shell, outside and inside. Today in this lecture, first of all, we will discuss outside point. Okay, so see, here it is. If point object is outside the Earth, means it is outside, of all spherical shell. It is outside of all spherical shell. For example, point is here. Okay. So see, this point is outside the earth. Yes or no? This point is outside the earth. It means it is outside this each and every spherical shell. Yes or no? Yes. So if point object is outside the earth, means it is outside of all spherical shell. And we know that for a point object outside spherical shell, force is acting on it such that it is acting towards center of cell. Yes, force is acting towards center of cell. Now, center of this each and every spherical cell is nothing but center of earth. Yes or no? Center of each and every spherical shell means center of earth. So yes, force acting on point object is towards center of earth. Clear about this? Okay, so now how to write? See, we know that point outside spherical shell, experiences force towards its center. Okay, we know that point outside spherical shell experiences force towards its center such that whole mass of shell is to be concentrated at its center. Clear about this statement? We already know this statement. Okay, we already know this statement. Okay, we know that point outside the spherical shell experiences force towards its center such that the whole mass of shell is to be concentrated at its center. Okay, so see here, for each and every shell, center is the center of earth. So what is conclusion? Conclusion is, okay, if point is outside the earth, gravitational force is acting towards center of earth. It is acting towards center of earth. Clear about this? If point is outside the earth, gravitational force is acting towards center of earth. Okay, because simply, okay, mass of each and every shell. If we add mass of each and every shell, then it is mass of sphere. Simple. Mass of this shell plus this, then it is mass of sphere. Clear about this? Okay, so first thing is clear. If point is outside the earth, gravitational force is acting towards the center of earth. Now, how to find acceleration? So I am assuming, okay, if object having mass m is at distance r from center of earth, where r is greater than re. Where r is greater than re. Now what is this re? What is this re? Here re is radius of Earth. It is radius of Earth. So if I say R is greater than RE, R is greater than RE means obviously point is outside. Point is, object is outside Earth. Okay, like this, you see. If it is Earth, it is its center, object is here. Okay, at distance R, at distance R, and it is R, that is radius of Earth. That is radius of Earth. We know that mass of Earth is m, and here we have to consider one object of mass. Clear about this? Hello? me, that is mass of Earth. me is mass of Earth. Okay, here I will write me. It is mass of Earth. Re, radius of Earth. Small r, remember in this chapter, small r is always distance from center of Earth. Small r is always distance from center of Earth. Small m is mass of object. Okay. So yes, how to find gravitational acceleration? See here. First of all, I will find force acting on object. Gravitational force acting on object. So see here. Gravitational force acting on object due to Earth. F is equal to, what is magnitude? How to find magnitude of gravitational force? It is, equation is G m1 m2 upon r square. G m1 m2 upon r square. Yes, m1 m2. So here it is G m me upon, what is distance between them? Object and center of Earth. Why center of Earth? If point is outside the Earth, gravitational force is acting towards center of Earth. So we have to take center of Earth. Remember, whenever you calculate any sum or any theory with respect to with respect to Earth, then you have to consider distance always from its center. Okay. So yes, it is its center. So it is, yes, here it is r square. Here it is r square. Now we know that how to find acceleration according to Newton's second law of motion. Yes, acceleration is equal to force upon mass. Acceleration is equal to force upon mass. So here I will write acceleration. See, F is gravitational force. So what is gravitational acceleration? Acceleration produced due to gravitational force is called gravitational acceleration. Simple. Okay, now acceleration produced due to gravitational force, due to gravity, is called gravitational acceleration. Is called gravitational acceleration. It's called gravitational acceleration. Clear? Okay, acceleration produced due to gravity is called gravitational acceleration. Any doubt? Any doubt? Okay. So yes, see now how to find this. Okay. See, here it is. Here it is. It is F. We know that gravitational acceleration experienced by object G is equal to, it is F upon m. Remember this equation. Gravitational acceleration G is equal to, it is F upon m. According to Newton's second law of motion, G is equal to F upon m. And yes, F, if you put what is value of F, then F is equal to, it is G m me upon r square divided by m. So m is, so therefore G is equal to, it is G me upon r square. G me upon r square. So it is equation of gravitational acceleration. It is equation of gravitational acceleration. Clear? When point is outside Earth, r greater than I. Simple. G, gravitational constant, 6.61 into 10 raised to minus 11, mass of Earth, and it is distance from center. Now if I say if object is on surface means here. This object is on surface. This object is on surface. Then what happens? Okay, so see, if object is on surface of Earth. Object is on surface of Earth. So simple here. If object is here, then how to write gravitational force? F is equal to G m a upon this distance is nothing but radius r square. Yes, it is r square. So see, you do not have to prove again this. Simple. In this chapter, whenever you are asked to find some quantity on surface, you have to just replace small r by its radius, that is capital I. Simple. If object is on surface of Earth, you have to replace small r is equal to I. Simple. So in last equation, if I replace r is equal to I, gravitational acceleration on surface of Earth, I can simply write as G is equal to G m upon I square. G m upon I square. Simple. And yes, you know what is value of G? G is equal to, it is 9.8 meter per second square. Clear? Any doubt? Okay, so this equation you have to remember. GE, why GE? It is gravitational acceleration on surface of Earth. G is equal to Gme upon I square. Now, after experiment performed by Cavendish, value of G was known. GE, that is gravitational acceleration, is also known. RE, radius of Earth, it is also estimated. Then, with the help of this data, you can easily estimate mass of Earth. So yes, after the experiment of Cavendish, he estimated mass of Earth. So there is one popular statement that Cavendish weighted Earth. Cavendish weighted Earth. Okay, so yes, it is acceleration due to gravity of Earth. Acceleration is due to gravity of Earth. And see, here it is acceleration due to gravity of Earth on its surface. Here it is outside. Now, acceleration due to gravity varies as we move up or down from surface of Earth. It means we are on surface of Earth. Okay, so if we are moving away, from surface of Earth, or we are moving towards the center of Earth, if we move towards center of Earth, then how gravitational acceleration varies. Now we will see that topic. Okay, yes, this topic is over here.